Hi, I'm Sean. Welcome to my maker portfolio. I started making stuff in the summer during COVID as a way to force myself to learn, beginning with a quadrupedal robot. I began by designing legs in CAD software and then 3D printed them to test their strength and stability on my desk. This also gave me a chance to design inverse kinematic algorithms, which allow my robot to calculate the angle of each of its leg joints given a demand foot position. This is indescribably satisfying. After various improvements, I designed and built the rest of the robot, including a custom circuit board. Following my tests with one leg, implementing inverse kinematics on all four proved simple, and I quickly developed standing rotational and translational movement with stability control too. I created a walking gait generator based on the desired walking speed, step distance, height, and the number of feet lifted at a time. With lots of testing and a lot of falling, my little robot could walk. But I realized that if the legs could feel pressure, it'd be easier to detect falls, so I created OpenServo, a replacement driver for small 20-kilogram servo motors. OpenServo is a combination of two boards, one equipped with a microcontroller, current sensor, and driver, the other with an encoder and a thermometer. This allows it to accurately control the absolute position, velocity, and torque output of the motor. It is designed to be placed into an existing motor as a stack-up, but my programming setup uses spring-loaded pins. I can connect to it over USB and a command line interface. With numerous PID controllers, OpenServo can turn with predetermined and configurable linear, exponential, and sinusoidal trajectories, which you can see on the command line plot. But I discovered that by controlling motor input voltage and power duty cycle that I could much more accurately control velocity and torque output at the same time. Here, each line is a different constant torque that also represents different velocities at that torque. With this in mind, OpenServo 2 is currently in progress. On my robotics team, Team Inspiration, I worked on the lower current power distribution system for the WAM-V autonomous boat and made a racquetball launcher for the Robotics competition. I also programmed an autonomous drone using a Pixhawk and Raspberry Pi 4 that can take off, fly, and land with GPS feedback and zero manual control.